Good evening, Srita. Srita, are you getting my voice?
Yes, sir.
In last class, we are discussing about the buffer solutions. Na? So what is mean by the buffer solution and how many types of the buffer solutions we are having? Ma? So buffer solution is nothing but the solution which prevents the change in pH by addition of excess of acid or base is called as a buffer solution. How many types of the buffer solutions we are having? Two types of the buffer solution. What are the two types of the buffer solutions we are having means? One is acidic buffer solution, another one is called as a basic buffer solution. So what are the buffer solutions we are having? Ma? We are having one is acidic buffer solution, second one is basic buffer solution. It is there. Okay. Is that clear?
Yes,
right.
sir.
So we had given some formulas also for acidic buffer solution and basic buffer solution also. Okay. Next, so we'll go for based on solubility product. Okay. We are going to discuss about here solubility product. Solubility product. Okay, so this is the one important concept. So based on this one also, simple numericals, formula oriented numericals only they're asking the examination. Okay, so what they're asking, ma? They're asking here simple calculations and formula based calculations only they're asking. Sir, what is mean by the solubility product and how you are going to represent the solubility product mean? Solubility product can be represented with KSP. Okay, how we are going to represent the solubility product, ma? Solubility product can be represented with KSP. Solubility product is defined as it is the product of molar concentration of the cation and molar concentration of the anion raised by their stoichiometric coefficients is called as a solubility product. Okay, so what is meant by the solubility product means here? Solubility product is nothing but it is the product of molar, it is a product of molar concentration of the cation to the power of x and molar concentration of the anion to the power of y. Okay, raised by their stoichiometric coefficients is called as a solubility product. Okay, so based on this one, let us see, sir, how we can calculate the solubility product means here KSP is equal to. So cation solubility we can take as a x s to the power of x. Here solubility of the anion we can take as a s to the power of y. Okay, if we simplify that one means what is the product you will get? So KSP is equal to s to the power of x plus y we will get. Okay, so based on this one we have a different types of the salts are there. So we have a AB type of the salt. AB type. Sir, what is the AB type means here? So what are the examples for the AB type means here? NaCl, NaNO3, NaNO3, KCl, KNO3, KNO3, okay, potassium nitride, and here. So all these are the rubidium chloride, lithium chloride, lithium bromide, sodium bromide. So all these are the examples of the AB type. Sir, why we are calling as a AB type of the salts means, for example, NaCl is undergoes to the ionization means it forms as a Na plus ion and Cl minus ion. Okay, Na plus ion and Cl minus ion. Sir, for this one, how we can write as a solubility product means solubility product KSP is equal to, it is the product of molar concentration of the cation and molar concentration of the anion. Sir, in this one solubility of the cation and solubility of the anion. Solubility can be represented with S. Solubility of the cation can be represented with S and solubility of the anion can be represented with S. So KSP is equal to S into S we can write as a S square. Then how we can calculate the solubility? Sometimes in questions one they had given as a solubility product. They are given as a solubility product. You have to calculate the solubility. Then how we can calculate the solubility? Means solubility is equal to square root of KSP. Solubility is equal to square root of KSP. Clear? Okay. Next. Here one more it is a AB type, AB2 type. AB2 type of the salt now. For AB2 type of the salt. Sir, for this one, how we can write as a solubility product means here, if AB2 type, it is going to be ionized means it forms as A plus 2 plus 2B minus. Okay, 2B minus. So that means how we can write the KSP here? KSP is equal to molar concentration of the S. This one, sir, here 2S it is there. That means 2S whole to the power of 2 we are taking. 2S whole to the power of 2 we are taking. That means how much we'll get as here? 2 square value S into 4S square. S into 4S square means we'll get as a 4 into S cube. Then what about the S value? S is equal to cubed root of KSP by 4. This is the one formula we are using to calculate the solubility product. Okay, and one more also it is there. AB3 AB3 also it will be there. AB3 also it will be there. Sir, what is the AB3 means here? Or A3B also we can write. Okay, AB3 or AB3 means we can write as A plus 3 and 3B minus. In this one, KSP is equal to A plus 3 and this one 3 to the power of, so B whole to the power of 3 ma. So then how we can write S into, so 3S whole cube. If we simplify that one means how much we'll get as here? S into 27S cube. Then this we can write as a 27 S to the power of 4. 27 S to the power of 4. Then we can write as a, so S is equal to 4th root of KSP by 27. Clear? Clear? Right now. Next. A2B3. For A2B3, what is the solubility product, ma? How we can write as a solubility product? For this one, we can write as a 2A plus 3 plus 3B minus 1. 2 minus it will be there. Plus 3B2 minus. So how we can write as a solubility product for this one? Solubility product is we can write as a KSP is equal to 2S whole square and 3S whole cube we can write. So this we can write as a 4S square and 9S cube. So 9 3s, 9 4s ma. How much will get? How much 3 cube means we'll get as a 27 here. Sorry, 27 into 4. 27 into 4 means we'll get as a 108. 108 into S to the power of 5. So this is the formula. So based on this formulas also we are having some of the calculations. Otherwise, directly they are giving us some formula. They're asking formula oriented question. What is the solubility product of AB2 type, A2B3 type or AB3 type or AB type here. So this kind of questions they're asking the examination part here. So this is also one of the important concept to us. Clear? So this is about ionic equilibrium. Everyone, you got the clarity, ma?
Yes, sir.
Okay. So tomorrow or day after tomorrow, I will give the questions based on only thermodynamics and chemical equilibrium, ionic equilibrium. Okay.
Okay, sir.
Sunday test it will be there. For Sunday test, I am giving us here chemical equilibrium, ionic equilibrium, and thermodynamics. These 2 chapters only. I don't want to give much more burden. Okay. Last time I had given 4 chapters under talk here. So this time, just I am going to give us 2 chapters. Last time, anyway, you wrote us some 4 chapters to question here. Okay. Tomorrow or day after tomorrow, I'm not sure. Okay. If today only, if I'm going to prepare the paper means tomorrow you have an exam. Okay. Clear? Otherwise,
Yes,
better you
sir.
write Monday, ma. I will inform them also. Okay. Better I'll write on Monday. Before Monday, I'll upload the paper. One day also will get
Okay,
the
sir.
preparation. Okay, Monday you're going to write the test. Okay, ma? Right, ma. So how many members they log in here? So all of you have a test on Monday based on thermodynamics and chemical equilibrium and ionic equilibrium. For the clarity, now once you checked out from 11th standard, what are the chapters we finished? Any one of you, how many chapters we finished from the 11th standard? The number of chapters finished from the 11th standard, ma. And which chapter? Next one is GOC, General Organic Chemistry, only it is there. Right, what are the chapters we completed from the 11th standard?
Sir, we completed 6 chapters.
6 chapters we completed 11 and 12th.
Two, sir.
12th also we completed 2 chapters. One is the solutions we completed and electrochemistry we completed. Almost all we completed 8 chapters. Okay, almost all we completed 8 chapters. Next, organic starts with directly. I'll give the slides only. I don't want to give more. Okay. Right, ma? So I'll try to finish by this month and your syllabus. Because of only in physical, you have a 2-3 chapters are there. Chemical kinetics it is there. Chemical kinetics only it is pending from the physical. Is it right, ma? What are the portions are there for MSET? P block elements is there? Actually, P block elements are deleted. That's why I'm asking. Is P block elements is there for exam? JEE NEET exam, P block elements are there. No one is giving information. Everyone are quiet. Either you know or not.
Sir, I think it's there.
P block elements 13th, 14th, 15th, 16th, 17th, 18th, 19th groups are there. Okay. Along with that one, so D and F block elements are there. Coordination compounds are there. In that one, I'm going to discuss about the coordination compounds. Because of coordination compounds is we have a weightage chapter. Okay. So remaining all are theoretical concepts only. If you read also, you can get the answer. Anyway, if you want briefly means I'll give the brief explanation one day. One day I can give the brief explanation for the whole P block elements. What are the important concepts you have to study also? That is also I can show in the slide wise also. Okay.
Okay, sir.
Got it? Right, ma? Next. Then the next important concept we are going to discuss about here, GOC. In this chapter, GOC and hydrocarbons only pending, ma. GOC, hydrocarbons. Okay. Redox reactions is finished. GOC, hydrocarbons is finished means 11th portions are finished. Right, ma? So GOC, today and tomorrow, day after tomorrow, I'm going to finish this. General organic chemistry. Okay, GOC is nothing but here general organic chemistry. So this one actually general organic chemistry is very big chapter. It's a very big chapter. General organic chemistry. Okay, so general organic chemistry is a very huge chapter and big chapter. It is not possible to complete. Okay, so within 3-4 hours, but I'll try to finish main important concepts. Okay, now, sir, actually, what is the main importance of the organic? Here, organic is signifies life. Organic is here signifies life, here. So signifies life. Okay, that means, sir, what is meant by the organic chemistry? Means it is a branch of chemistry which deals with the study of the compounds which are obtaining from the living organisms is called as a organic chemistry. So what is meant by the organic chemistry, ma? Organic chemistry is a branch of chemistry. It is a branch of chemistry which deals with the study of the compounds which are obtaining from the living organisms is called as a organic chemistry. Okay, so that means organic compounds are containing carbon, nitrogen, oxygen, sulfur, phosphorus. In this one, if you observe carbon, nitrogen, hydrogen. In this one, which elements are present in their high quantity means here carbon, hydrogen are they present in the large quantity. If you take any organic compound means here which elements are present in a larger quantity means here carbon and hydrogens are they present in a larger quantity while comparing with the nitrogen, oxygen, sulfur and phosphorus. Okay, for this one different scientists were they had given us a different definition for the organic compounds. Okay, that means organic compounds, they had given some different definition for the organic compound. Sir, who has given the definition? First definition means here, Lavoisier. So Lavoisier is called as a father of chemistry. Who is the father of chemistry means here? So Lavoisier is here, father of chemistry. Okay. Lavoisier is father of chemistry. Father of chemistry. Lavoisier is here, father of chemistry. Okay, in this one, Lavoisier he has given one definition. What is the definition has given the Lavoisier means here? According to the Lavoisier, okay. So the here the compounds which are obtaining from the living organisms is called as a organic compound. The compounds which are not obtaining from the living organisms is called as a inorganic compounds. So what is with the organic compounds, ma? Organic compounds are nothing but here the compounds which are obtaining from the living organisms is called as a organic compound. The compounds which are not obtaining from the living organisms is called as a inorganic compound. Sir, what are the examples of the organic compounds means here? Glucose, fructose, mannose, proteins, amino acids. Okay, so nucleic acids. All these are the example of here organic compound. Okay, the compounds which contain the carbon and hydrogen along with that one other elements is called as a organic compound. Okay, this is the first scientist. And Berzelius also he has given some definition. Berzelius. So Berzelius. Okay, so Berzelius is all. Okay, so here Berzelius also has given some statement. Sir, what is meant by the statement means here? So Berzelius, he told that organic compounds are produced from the living organisms. Okay, so actually one statement is that my exactly means here. So Berzelius, exactly 1 second, I will tell here. Berzelius one classification and here vital force theory. So what is meant by the vital force theory? What is meant by the vital force? So who proposed the vital force theory means here Berzelius scientist. What is meant by the vital force? Vital force. Sir, what is meant by the vital force means vital force is nothing but some hidden energy it is there in all living organisms. So simple example I'll tell one thing here. Every day, okay, so we are having some food. How the food is going to be digested in a body and what are the food we are having, how it is converted into the energy, how it is converted into energy, ma? Is any reason? After having the food, how it is digested? In the digestive, the digestion means here, so digestive system it is there, in digestion process it is there, in that one enzymes are involving and some acids are they releasing here. Okay, now my question is, in the digestion process you are telling that some acids are releasing and some enzymes are they act as a biocatalyst. Generally enzymes are we can call as a biocatalyst. Okay, so what is the main function of the biocatalyst means here? So they breaks the high molecular mass substances into low molecular mass substances. Whatever the food we are taking, they're having high molecular mass. That they make it as a simple molecules. After that, so it is going to be dissolved by here. Okay, it is converted into the energy. That energy is absorbed by the cells. All these functions to happen, all these functions, some hidden energy it is there in all the living organisms. That hidden energy only we can call as a vital force. Okay, if a vital force is not there in a living organisms, means digestion is not possible. Whatever the food we are taking, that it is also not going to be digested. Okay, if you won't take the food, means what happened? After a few days, we are going to be die. So, but that thing is not happening here. So, why it is not happening is due to the presence of the vital force. According to that one, Virgilius is telling that, so due to the presence of the vital force only, organic compounds are produced in a living organism. Okay, vital force is not that, means organic compounds is not produced. Okay, next. Here, next one. No, no. So what is the next one means here after the Virgilius? Who proposed the first? Who distinguished the first organic compound in laboratory means here Frederick Kohler. Okay, so who isolated the first organic compound means here Frederick Kohler. So what is the first organic compound he prepared the in laboratory means here urea. Okay, what is the first organic compound they synthesized in the laboratory means here urea. So who synthesized means here Frederick Kohler. Okay, Frederick Kohler, WoHler. Okay, so what is the name of the scientist means here Frederick Kohler. Frederick Kohler is synthesized the first organic compound in the laboratory. Okay, so what is the organic compound is synthesized in the laboratory means here urea. Okay, and Kolbe is there, my friend. Okay, so Berthelot he prepared the methane. Berthelot, he prepared the methane. He prepared the methane. Okay, so all these are the different scientists. They isolated the different components here. All these are different scientists here. They isolated different compounds. Okay, now let us see. Nowadays, if you see, means we have a large number of the organic compounds. So many organic compounds we are taking in the form of medicine, we are taking in the form of food and at all. Okay, sir, how they prepared all these compounds, how they isolated all these compounds means here. So based on material. Okay, so why, how these exist, these many compounds means because of in all the compounds, carbon is the major element. In all the compounds, which one is the major element? Ma, carbon is the major element. Okay, now due to the presence of the carbon only. Sir, why the carbon is forming these many elements means because of carbon is having high catenation capacity. Because of carbon is having high catenation capacity. Because of carbon is having high catenation capacity. Okay, another one. And the carbon is having tetravalency. Tetravalency. And the carbon is having tetravalency. Clear? Sir, what is meant by the high catenation capacity? High catenation capacity. Make it fast one. We'll go a little bit fast. What is meant by the high catenation capacity, ma? My catenation capacity is nothing but ability to form longest chains and cyclic rings. Okay, or how we can define as the catenation capacity means catenation capacity is nothing but it is has a tendency to form the bonds with itself, and it can form the bonds with other elements also like oxygen, like nitrogen, like sulfur. Okay, and it has a tendency to form as a longest chain, and it has a tendency to form as a cyclic rings also is called as a catenation capacity. So what is meant by the catenation capacity means here catenation capacity is nothing but tendency to form the bonds itself and other elements also, and it has a tendency to form as a longest chains and cyclic rings also we can call as a catenation capacity. So due to that reason only carbon it forms as these many of the organic compound, some million number of organic compounds we are having here. And what is meant by the tetravalence? What is meant by the tetravalency? Tetra means here 4 and valency. So which one is having the tetravalency means here carbon. Carbon atomic number is equal to 6. The electronic configuration of the carbon is written as a 1s2, 2s2, 2p2. In outermost orbital, how many electrons are there? 4 electrons are there. In s orbital, we have 2 electrons. Okay. In p orbital, we have 3 subshells. How many subshells are there? 3 subshells are there. In that one, it is a ground state electronic configuration. This one is here ground state electronic configuration. Okay, if you take excited electronic configuration, sir. In excited state means what happened here? The electron which is present in the 2s orbital is jumps into the 2p orbital. So that time in s orbital we have a 1 electron and remaining p orbitals. Each orbital is containing 1 electron. So we already discussed about the covalent bond. So covalent bond means mutual sharing of the electrons between two atoms is called as a covalent bond. So what is the covalent bond, ma? Covalent bond is nothing but it is a mutual sharing of electrons between two atoms is called as a covalent bond. So each carbon it exhibits as a how many sigma bonds means here it has a 4 sigma bonds. How many sigma bonds it is going to be formed here? It forms as a 4 sigma bond. Okay. So based on the number of based on the number of sigma bonds also, we can explain the type of the hybridization. Generally, organic compounds are the exhibit as only 3 types of the hybridization. Organic compounds are the exhibit as only 3 type of the hybridization. They won't exhibit as a more than 3 type of the hybridization. Sir, what are the 3 types of the hybridization we are having means here? Okay. Here, sp3 hybridization, sp2 hybridization, sp hybridization. Sir, so when we can take as a sp3 hybridization means if the carbon is surrounded by the 4 sigma bonds. If the carbon is surrounded by the 4 sigma bonds means then it exhibit as a sp3 hybridization. If the carbon is exhibit as a 4 sigma bonds means exhibit as a sp3 hybridization. Sir, all single bonds are we can consider as sigma bonds. All single bonds are we can consider as a sigma bond. Sir, what is the best example for the sp3 hybridization means methane. Generally, we can call as a alkanes. Alkanes are the best examples of the sp3 hybridization. Okay. So now carbon is surrounded by total how many sigma bonds means 4 sigma bond. That's why it exhibits as a sp3 hybridization. In sp3 hybridization, percentage of the s character. sp3 hybridization means percentage of the s character is equal to 25%. Percentage of the p character is 75%. How much percentage of the p character is there? 75% it is there. Okay. In this one, what is the bond length? Carbon-carbon bond length. Carbon-carbon bond length is 1.54 Armstrong units. Okay. And bond angle. What is the bond angle in between the carbon-carbon means here 109 degrees 28 minutes. Okay. Next, if the compound in the carbon is surrounded by 3 sigma bonds, 1 pi bond, 3 sigma bonds and 1 pi bond. Sir, when we can take as a pi bond means whenever the carbon-carbon multiple bonds are there, it may be double bond or triple bond. If it is having double bond means in that one is the sigma bond, another one is pi bond. Okay. If it is having triple bond means in that one is the sigma bond, remaining 2 are the pi bonds. Okay. Now while having the 3 sigma bonds, 1 pi bond. Okay. So what is the example means CH2 double bond, CH2 alkene. Okay. CH2 double bond, CH2. If the alkene in this one, 3 sigma bonds, 1 pi bond it is there. Okay. What is the hybridization of the S character means 33.3%. What is the percentage of the P character means 66.6%. What is the bond angle means 1.34 Armstrong units. What is the bond length? What is the bond length between the carbon-carbon means here 1.34 Armstrong units. And what is the bond angle means here 120 degrees angle. How much it is here? 120 degrees angle. Okay. And if it is having sp hybridization, when we can take as a sp hybridization means here, so 2 sigma bonds and 2 pi bonds. 2 sigma bonds and 2 pi bonds. While having the 2 sigma bonds and 2 pi bonds, it exhibits as a Okay, it exhibits as sp hybridization. Sir, what is the best example? Means acetylene, set C triple bond CH. In this one, in between the carbon, one sigma bond, two pi bonds are there. In between the carbon and hydrogen, we have a one more sigma bond. So total number of sigma bonds for the carbon is two sigma bond, and total number of pi bonds is equal to two pi bond. Two sigma bonds and two pi bonds. Okay, what is the percentage of the S character? Means 50%. What is the percentage of the P character? Means 50%. Okay, percentage of the S character is 50%. Percentage of the P character is 50%. What is the bond length? Means here 1.20 Armstrong units. Bond angle 180 degrees. What is the bond angle? 180 degrees. So this is about the type of hybridization, bond length, percentage of the S character, and all. So based on this one also, sometimes they're asking the questions. What are the types of the questions they're asking means here? So calculate the total number of sigma bonds in a given molecule. Calculate the total number of sigma bonds and pi bonds in a given molecule. For that one, I'll give one example. My question is simple question. I'll ask my here. I don't want to go for more here. CH2 C double bond ethene. In ethene, the total number of sigma bonds and pi bonds. Total number of sigma and pi bonds. How many sigma bonds and how many pi bonds are there in a given molecule? CH2 double bond CH2 ethene. Ethene. How many sigma bonds and how many pi bonds are there? Niharika. Niharika, how many sigma bonds and how many pi bonds are there? Niharika is there. Niharika is there, Samgita is there, Sriyuta is there, Javian is there. The total number of sigma and pi bonds in a given molecule, ma. Niharika.
Sir, 5 sigma, 1 pi.
Very good, sir, Sriyuta. So 5 sigma bonds and 1 pi bond. Okay, 5 sigma bonds and 1 pi bond. Okay, ma, I would like to ask one thing, all of you. Anyway, either it is correct or not, I don't to ask you. All of you understanding my classes or not, first of all?
Sir, I'm understanding well.
Same, sir.
Sir, you're understanding. Samhita, what about you?
I'm understanding, sir.
Okay. Niharika?
Yes,
Niharika, are you understanding my classes or not?
Yes, sir.
Okay. Javian? Javian? Okay. So why I'm asking means here, in portal some rating is there. Rating of the classes. 10 out of 10 something it is there. Rating. In WISE app only. For every faculty, after finishing the class, I think so some rating they kept. So rating is not there for my classes. Generally, I got it out. Whether you people are understanding or not. Okay. Hope so. I'm going a little bit fast. That I know. I know, really, I'm telling that I'm going very fast. But my intention is, so you came for the crash course. Okay. In crash course means what are the information in a short period I want to provide, that I'm trying to provide you. That's it. Okay. So while checking the classes, while checking the videos, so better once you check it out the rating. Okay. So if you give good rating means it's okay for me. Okay, ma.
Okay,
I
sir.
think Samrita, she has given some rating. I didn't observe others here. Okay. So once you check it out, if any rating and at all this much. So if you're satisfied means then only you can give. No issue. If any changes means here, just you text me. I will try to change. Okay. But crash course means I can go this much of fast only. Actually, I tell that to be frankly, I'm going a little bit slow only. But if it is offline class means I used to go a little bit fast. Generally, I used to take some slides only. Because of when I am going to explain the slides, means some people they told that, sir, by taking the slides in the all, we are not understanding. Okay, so that's why I'm writing. Otherwise, here also I used to provide slides only. Okay, that is there. For organic chemistry compulsory, upcoming chapters I'm going to take as a slides only. Writing part and it won't be complete. Okay,
Okay,
right,
sir.
ma'am. Right, ma'am. So now, how many sigma bonds and how many pi bonds are there? Means here, this one is containing total 5 sigma bonds, 5 sigma bonds and 1 pi bond. Total 5 sigma bonds and 1 pi bond is that. Actually, one previous year question it is that. So what is the previous question means? The total number of sigma bonds and pi bonds. I think so. This question already we explained at the hybridization part. Previous year question. C2 CN taken 4 times. C2 CN taken 4 times. Tetracyanoethylene. What is the ratio of the number of sigma bonds and pi bonds in a tetracyanoethylene? We got as a 9:9 is the ratio. 9 sigma bonds, 9 pi bonds. That means you look at as a 1:1 is the ratio. 1:1 is the ratio. Okay. And based on this one, if you are NCERT textbook, sometimes they're asking the previous questions also here. So they're asking the questions based on the hybridization also. Either MSET level, KSET level. Okay. So set level examination, some questions are asking here. For example, what is the question with CH3 bond? CH double bond, CH bond, CH3. So what is the hybridization of the each carbon atom in a given molecule? What is the hybridization of each carbon atom in a given molecule? What is the hybridization of the each carbon atom in a given molecule?
So the last two are sp3.
What about the middle one?
Middle one is sp2.
Middle one is sp2. Middle one also sp2 and one more also sp2 it is there, ma?
Yes, sir, both of them are sp2. That's what I'm trying to say.
Okay. So both are sp2 only. So what is the hybrid? What is the ratio of the sp2 and sp3 hybridization? What is the ratio of
1:1.
Ma?
1:1.
Very good, ma. So 1:1. Okay. So what is the ratio means here? 1:1. Okay. Clear? Still anybody having doubt here?
No, sir.
No. If I'll write one more question here. What is another one means here? So what is the hybridization of the each carbon atom in a given molecule? What is the hybridization of the each carbon atom in a given molecule?
SP2, SP, SP2.
Very good, ma. So sp2, sp2. This one is sp2, this one is sp, and this one is sp2. Sir, how it is sp2 means here? This carbon is surrounded by the 3 sigma bonds. Sir, how you are telling that means each hydrogen it forms as a 1 sigma bond. Like the total number of hydrogens means we have a 2. That means the 2 are it forms as a 2 sigma bonds. And if you see in between the carbon we have a double bond. In that one is the sigma bond, another one is the pi bond here. So now only I told that if the carbon is surrounded by the 3 sigma bonds means it exhibits as a sp2 hybridization. While coming to the second carbon atom, so this side also 1 sigma 1 pi, this side also 1 sigma and 1 pi. The total number of sigma bonds is equal to 2. If it is 2 sigma bonds means it exhibits as a sp hybridization, and the last one also it exhibits as a sp2 hybridization. So based on this one, some examples are there. Okay, so once you check it out, that examples so clear. Okay, next month. So classification is not required. Okay, so classification is required, ma. think so classification is not required, but in this one, some concepts are there that I'm going to be explained here. So what is the classification of the organic compound? Classification of organic compound. Classification of organic compound. Organic compounds. Organic compounds are classified into two types. One is open chain compounds. One is open chain compounds. Another one is closed chain compounds. Another one is here closed chain compounds. One is open chain compounds. Another one is closed chain compounds. Okay. Again, closed chain compounds are they classified into two types. One is homocyclic compounds. Homocyclic compounds. And another one is heterocyclic compounds. Heterocyclic. Sir, closed chain is nothing but cyclic rings. What are the cyclic compounds we are having? Cyclopropane, cyclobutane, cyclopentane. Here, so homocyclic means the cyclic rings are containing all carbon atoms, means that we can call as a homocyclic. Sir, what is meant by the homocyclic ring means here? The cyclic rings which are having all carbon atoms is called as a homocyclic compound. Heterocyclic compounds mean the cyclic rings. In a cyclic ring, one carbon atom is replaced by either oxygen, nitrogen, sulfur is called as a heterocyclic compound. Sir, what are the examples of the heterocyclic compounds means here? One is furan, one it is the tetrahydrofuran. This we can call as a tetrahydrofuran. Another one is tetrathiophene. Thiophene. Okay. Pyridine. Pyridine. Pyridine is nothing but six-membered ring. So pyridine is nothing but here it is a six-membered ring. And pyrrole. Pyrrole. So pyrrole is nothing but this one. So this we can call as a pyrrole. So based on this one also sometimes they're asking the question, which of the following they're giving us some structures. In that one, which of the following is the heterocyclic ring? What is meant by the heterocyclic ring means here? In a cyclic ring, one carbon atom is replaced by other elements. What are the other elements means? Either oxygen, nitrogen or sulfur, means that we can call as a heterocyclic compounds. In this one, again, homocyclic compounds are classified into two types. So one is alicyclic compounds. Alicyclic compounds. Another one is aromatic compounds. Another one is here aromatic compound. In this one, alicyclic rings are nothing but aliphatic. Alipha means saturated here. Here we are getting as a saturated. Sir, what is meant by the saturated or unsaturated? Saturated or unsaturated. When we can call as a saturated means if the carbon-carbon we are having single bond, means that we can call as a saturated. What are the best example for the carbon-carbon single bond means alkanes. Okay, and unsaturated. Unsaturated. So which we can call as unsaturated hydrocarbons means here, if the carbon-carbon multiple bonds are there, means either double bond, either it may be triple bond, it is there. That we can call as unsaturated. Okay. So what we are calling means alicyclic. Alicyclic means here aliphatic saturated cyclic compounds are we can call as a alicyclic compound. What are the examples of the alicyclic compounds means here? Cyclopropane, cyclobutane, cyclopentane, cyclohexane. All these are the examples. Okay, and tomorrow we'll discuss about the aromatic compounds. Actually, it is a big concept. Now I can't complete this one here. That's why I'm postponed to tomorrow. Okay, so we'll continue in tomorrow class. Again, one more class I'm having here. Okay, thank you all.
Thank you,
So
sir.
please check it out rating. Once you check out the rating today, okay, and give us. Right. Thank you all. Today Javian is not responding.